question, we need to convert 25 kilometer to centimeter. Okay, first 25 times kilo is 10 to the power of 3, and we need to divide because kilo we want to convert it to centimeter, we need to divide. So centi is 10 to the power of -2. So we get 25 times 10 to the power of 3 times 10 to the power of 2, because it's -2, we go like this, so -2 become 2. Okay, and the answer is 25 times 10 to the power of 5, because time we need to plus, and divide we need to minus. So we get 25 times 10 to the power of 5 centimeter.
Is 3.464. So for the y component, we need to put -4 sin 30. Why negative? Because this is downwards arrow, so the answer is -2. So for 5 Newton, this here, we need to put this arrow right and upward. So for the x-axis, we need to put 5 sin 25. So the answer is 2.113. So for y-axis, we need to put 5 cos 25. So the answer is 4.532. So for the last one, it's 3 Newton. We need to put this for left arrow and downward arrow. So for the x-axis, which is here, we need to put -3 sin 50. So the answer is -2.298. So for y-axis, which is downward 2, we need to put -3 cos 50. So the answer is -1.928. So next, we need to find the resultant, which is based on the question. So resultant, we need to find sum of the x component and y component. So first 3.464 plus 2.113 plus -2.298. So the answer is 3.279 Newton. So for y-axis, we need to sum 4.532 plus -2 plus -1.928. So the answer is 0.604 Newton. So next, we need to find the magnitude. So magnitude, we need to use theorem Pythagoras formula. So 3.279, which is x component, plus 0.604 squared. So the answer is 3.341. So last for direction, we use tangent theta, so equals 0.604, which is y component, divided by 3.279. So the answer is 10.44 degree. Okay, for the third question, you need to determine the object's distance travel to displacement. Okay, first we need to find distance. Okay, so distance we need to find using area under the graph. So first we use formula 1/2 times 2 times 3 because of this 2 and 3. So second we need to use this formula. Okay, so we need to plus 2 times 3. Then next triangle, which is half, times 3 times 3, plus another triangle, which is here. Okay, 2 times 2. Finally, plus this triangle, 2 times 1. So 2 times 1. So we get 3 plus 6 plus 4.5 plus 2 plus 2. So we get 17.5. So for displacement, we use the same formula, which is area under the graph, but we need to concern the positive or negative, which is up or under the graph. So 1/2 times 2 times 3 plus 2 times 3 plus 1/2 times 3 times 3. So okay, for this 1/2 times 2 times -2 because of this, which is under the graph. So plus -2 again times 1. So so we get 3 plus 6 plus 4.5 minus 2 minus 2. So we get 9.5 meter. Okay, for the next question, we need to find the object's position at t 2 seconds, 7 seconds and 10 seconds. Okay, one question, given t equals to 0, object's position is x equals to 2m. So firstly we need to write t equals to 0, so that x equals to 2m. So to find t equals to 2s, so x need to find using the same formula, which is triangle formula again, and then we plus with this before object's position, so 2. So we get 5m. So for t equals to 7 seconds, so for t equals to 4 seconds, x, so we need to use the same formula, So 2 times 3 plus 5 using this. So we get 11m. So next 40 equals to 7 seconds. So x by 1/2 times 3 plus 11. So we get 15.5. So for the last one, t equals to 10 as x equals to 1/2 times -2 times 2 plus 15.5. So we get 11.5 meter. Okay, for the next question, we need to find object's acceleration at the following times: t equals to 1s, 3s, and 6s. So first, 40 equals to 1s 1 second. So for the acceleration, we get 3/2 based on the formula. So for 1.5 ms -2. So for t equals to 3s, the acceleration is 0 because at that time the object is rest, so the acceleration is 0. So for t equals to 6s, acceleration to 0 minus 3/7 minus 4. So the answer is -1 ms -2. Okay, for the last question, we need to sketch the graph acceleration versus time. So based on that question before, we find the acceleration of 2 seconds, 4 seconds, 7 seconds, and 10 seconds. We easy to draw, to sketch the graph. So for 0 second, the acceleration to 2 seconds is 1.5, which is here. So we need to underline until the point, this point. Okay, so we need to touch down. So for 2 seconds until 4 seconds, the acceleration is 0. So at this line and straight line at the x-axis. So and then for 4 seconds until 7 seconds, the acceleration is -1, which is here. So at this point to this point, so we just underline this, just connect them. Okay, so at the last one, 7 seconds until 10 seconds, the acceleration is 0. So at this line 2. So that's it.
Okay, for the next question, we need to find the velocity at 7 seconds. Okay. For the first step, we need to find the area under graph. Okay, this is a A. So B, C, and D. Okay, for the A, we use 1/2 6. Okay. So we get 3 for the A. And for the B, we use t minus 1 and 6. So we get 2 times 6. So we get, okay, for the C, we need to use 1 over 2 times 6 times 2, and we get 6. Okay, for the D, we need to use 1 over 2 to so we get 2. Okay. Okay, the area under the graph, we need to total all the area. So 3 plus 12 plus 6. Okay. For the D, we need to minus because the D under the graph, so it's negative 2. So we get 19. So we need to find the velocity. Okay, the velocity we need to use this one, m v w. So we get this, we get 19. So m 2 kg. So we need to find, and minus 10. So we get v equal to 19.5 meter per second. Okay, for the next question, we need to sketch the free body diagram. Okay, for the first system, we sketch like this, and like so. This is a normal. This is a T. It's a for F. It's a T. So this is a W. So this is a 45 degree. Okay, for the second system, it sketch like this. So done. So the next question is we need to find tension.
Yeah.
Okay, for find the tension, we use sum Fy equal to 0. So y we get T minus W equal to 0. So Wt equal to mg because W equal to mg. So we use T equal to 5 cos 5 kilograms and we times to gravity 9.81, so we get 49.05. Okay, for the second system, we use F plus T minus Fg minus W sin 45 equal to 0. So F, we get 0.2 times 69.37 plus sin 45 minus 49.05. So for the F, for the force we get 34.90 Newton for the second system. Okay. For the D, we need to find acceleration. So we use sum Fx equal to ma. So Fx, we get T minus F plus F minus Fg minus W sin 45 degree equal to ma. So for the T we get 49.05 and for the F we get 34.90 and for Fg we get 69.37. So for the and times 0.2 minus 9.81 times 0.71 equal to ma. So we get for the left side we get 62.40 equal to 10a, and for the A we get 6.24 ms negative. Okay, for the next question, we need to state 3 laws of Newton, and the first law is state an object at rest will remain at rest or continue to move with uniform velocity in straight line unless it is attacked by an external force, and or by a symbol we get this. The first law gives the idea of inertia. Inertia is tendency of an object to resist any change in its state of rest or motion. So the second law is the rate of change of linear momentum of a moving body is proportional to the resultant force, and it is in the same direction as the force acting on it, and this is a symbol. Sum F equal to resultant force, and delta P equal to change in linear momentum, and delta T is time interval. Okay, and this also get this and this. Sum F equal to ma. Sum F equal to resultant force, m equal mass of an object, and a is a acceleration. So for the last law is every action force has a reaction force that is equal in magnitude but opposite in direction. This like this. This is an example of third law. So this third law to FAB equal to negative FBA. So it is opposite in direction. Yes. Okay, we done.
Okay, for question 7, we need to define work. So work is defined as a force causing the movement or displacement of an object in the case of a constant force. Work is the scalar product of the force acting on an object and the displacement caused by that force.
Okay, for the next question, we need to find work done, energy, and velocity. Okay, for the first step, we need to find the mass. So we use N equal to kg ms negative 2. So we get for N we get 2 cos 2 Newton and 9.81 times. So we use the unknown x, so we need to find x. So x equal to 0.2 kilogram. So we need to find the energy. So we use MGH. So M equal to 2 and H 2 times 16.25. So we get 32.5 joule. So energy settle. So we need to find work. Okay, to find work we use F times S. For the S we get 2 cos 0 times 7. So we get 40 joule. Okay, so the last we need to find velocity. So we use the sum K sum KF. So we get 1 over 2 mv squared mgh times, so we get is plus, so we get 1 over 2 mv2. So this for 1 over 2 mv squared we get 1 over 2 m cos 0.2 times 2. So we need to square, so plus mgh we get 32.5, so equal to 1 over 2 m, and we get 0.2 times v squared. So for the left side we get 32.58, and for the right side we get so for the V we get 18.03 ms negative 1. So we done.
For the last question, we need to define Newton's law of gravitation. So, Newton law of universal gravitation states that every particle attracts every other particle in the universe with a force which is directly proportional to the product of their masses and inverse inversely proportional to the square of the dia